Today we're going to talk about neural network for reinforcement learning algorithm, and let's look in review of my code. So this main function train, when we can run this function and this file using this command line python train.py, and it means we run process to train our algorithm. Using array distribution learning, we can train on different remote server in one times, and we can increase effectivity to train our agent. So you see, when we create our agent, we need to input some brain. This is architecture of neural network. Let's look at this agent. So this is the DQN agent, and inside this agent we should input another class. It will be architecture of neural network, and then we can train this one. You see, let's look at this is brain, and using this brain, you see, we can create some actions and do a replay of our experience of neural network. Okay, let's look at architecture of this neural network. So I have several architecture. I have some simple brain DQN. It's like for testing, make sure that my script is working, some debugging parts. Okay, I just demonstrate for you how it's working. For example, I run this command line, and what we do initialization of our neural network. Let's wait a few seconds. Yeah, only once time we do an initialization, so we create the common neural network, and then we create multiply trash, and then we can train our neural network. In my case, I create about, for example, 6 parallel training process of 7. Okay, so it's working, and then we store some information to logs, so we can do monitoring this information using TensorBoard. Okay, so let's do overview how it's working. So this is the brain of neural network. This is folder agent, and there exist several architecture of neural network. Something simple, it's more complicated, some complex brain, and then combination between LSTM model, dense model, convolution, and more complicated using GRU model, attention mechanism, and something very complex, very complicated model. Okay, let's do a review because it's cryptocurrency market, and we need to find something. A dependency, complex dependency, and we need more data and some complicated neural network. Okay, so how it's working, for example, is start state size. Means we got the state from our gym, from our environment, and also we input action size. It means how many actions we have in our environment. For example, right now I have 5 actions. For example, open long, close long, open short, close short, and hold. Yeah, 5 actions. It's model name. We need to save this model when we train our agent. We need to save this one, and this stuff we need to test our model or for production. We can upload this one, and then we can predict. Okay, so first of all we need to input this. We need to create the first dense layer, and we need to indicate what is the input data. It would be state size. In my case, when I run this stuff, it would be 50 window back. Yep, window back. And then we indicate how many neurons we have and what is the activation function. Relo is working fine. You can read about Relo function. And then we decrease number of neurons, and then the last layer would be liner, activation function liner. It's like by default, and we input number of our actions. See? And then we compile it using mean square error. We're using Adam algorithm for optimization, and learning rate indicators. It's like some by default, but of course we can tune all this stuff. So it's very something simple. Let's look in more complicated what I'm using. So I'm using this is the same. You see we have the same input for all neural network. For example, this one, same input. Also the same initialization, you see, action size, number of states of size, it means 50 window back, and then create our neural network. We build our neural network, and then let's look in more complicated neural network. What we're going to do, so of course we indicate input layer, yeah? And we have this 1D an array, only closed data of price without any indicators, and the last 50 window back. But of course we can add more indicators, and we can create another input. Okay, but let's look for step by step. And then we create our convolution layer. Convolution 1D, it means we input 1D an array, and we create several filters with the kernel size and activation function, and we can extract feature, high level feature. And when we extract this high level feature, we do flatten this one on the big 1D array, and then we convert this one on dense layer. Of course, I'm using dropout. It's some forget function for neural network, and when it means 30% of neurons would be dropped from this neural network, and neural network could train more effectively. And then we call after dropout another dense layer function with activation function relo, and then we can use attention mechanism, and there we're trying to find what is the most important from this one 1D array, and we do this merged, and then we need to call several times our dense layer function, and on the last of this dense layer function we call regularization L1, L2. It means we're going to solve problem of overfitting, and then we call like relu, this activation function, and we do, of course, the output layer would be the same for all neural network, and you see we have the same output for all neural network. You see, for example, if I take the some simple brain, we have the same output because we need to output number of our action size. Means input and output would be the same for all neural network, like this one, where is input layers and output layers would be the same. Okay, and so in this my main neural network, when I develop this algorithm, and then let's looking for another one. It would be like complex brain decune. Okay, we skip it. It would be like the this one, but more complicated, because we add more dense layer function, more activation function, and yeah, and without, yeah, of course we add some dropout to avoid of overfitting. And let's look in another. So input will be the same. Let's look in. We extract using convolution layers. We extract high-level feature. We create two filters there, two layers, and then we do flat. It's when we after convolutional neural network, we need to call a flat, and then we can do another manipulation. We can input to LSTM model or do some reshape and input another layers. In this case, we input the stuff to LSTM model, and of course we return sequences true, because we're going to use several LSTM model, and the first LSTM layers should be return sequences true, and then all these neurons we input another LSTM, and the last LSTM should be without return sequences true. Okay, then we do this processing, because we need to create the same shape to input all the stuff to attention mechanism, and then we create some dense layer and concatenate all this feature from dense layer and from attention mechanism, and then we're going to add the similar parts what we done using regularization when we create this merged layers, and we do some regularization, and then we can output all the stuff to number of our action size, and then we can call. Okay, this is it was some complicated LSTM brain, then super complex brain DQN. It would be the same, but we done some GRU models. We also create this concatenate feature there. It would be like merge layers, and then we do the same. We call regularization L2, yeah, and then we do output. Output should be action size, number of our action size, and then we create some ultra complex brain. It's a combination of all of stuff what we done before, and also we add some batch normalization. It increases speed process for training. What else? Okay, it's combination of LSTM GRU, and then yeah, of course we've done some reshape, because we need to create this required number of neurons to our attention mechanism. Yeah, and there we use scale because before we didn't use this one. And then we call all this stuff, and then we do the same stuff. We create a merged, and after this merged we call several dense layers, and of course we use regularization L2, and then we do output of our neural network. This would be a number of our actions. So for example, right now I used simple neural network. Let's take in, for example, ultra complex. Yeah, this one. Okay, let's look in. I'm not sure, maybe my laptop would be freeze, but I tried to run this one. So in the previous video have done array, and it means I can run this reinforcement learning algorithm on a remote server, and I can connect a multiplier of server and train all this stuff. But before this one, I need to work on environment and done some very useful feature. We need to create a pre-processed memory, and I show you in next video how to create this one. We need to increase process of training. Okay, you see it's working. Okay, I stop this one. Okay guys, I hope this video would be useful for you, and you can use this approach to develop your reinforcement learning algorithm. Thanks, see you next time, bye.